This is question number 34 from the August 2016 Algebra 2 exam. So we're dealing with an iodine isotope, and we're told that the half-life of it is 8.02 days. We also know that a patient's being injected with 20 milligrams, and what we need to find is the amount of time needed for that amount of milligrams to decrease to 7 milligrams. So in order to solve this question, you would have to have memorized the half-life formula, and that would be that the final amount is going to be equal to the initial amount multiplied by 1/2 to the power of T over H. Now we do know that the half-life is 8.02 days, so we can put that in there. Great, so now we've got an equation, and we're going to be solving for T. Now because our unknown variable is in the exponent, the trick here we're going to do to solve this is to take the log of both sides. But before we do that, we can simplify this expression or equation a little bit by dividing both sides by 20. And then we would get, let's see, I guess 0.35, if we're turning it into a decimal, is equal to 0.5 to the power of T over 8.02. Okay, so now we're going to take the log of both sides. And then we're going to use that trick where we're able to take this exponent and move it to the front of the log. So let's write that out. So log of 0.35 is going to equal T over 8.02 multiplied by log of 0.5. And so now we just have to do a little bit of manipulation to isolate T. So we can do that by multiplying 8.02. Just going to move up here. So we'd have 8.02 multiplied by log of 0.35. And then to get rid of this log of 0.5, we would divide by log of 0.5. And that's what T is going to equal. So when you finish calculating that out, you should get a T value of 12 if we're rounding to the nearest day like they want us to. So I guess we should write 12 days. All right, that would be it for this video, and thanks for visiting JD's Regents Preparation.